Here's our third definition for the trigonometric functions, and it involves the unit circle. Now, I've drawn the unit circle over here on a coordinate system. The equation of the unit circle is x squared plus y squared is equal to 1. It has a radius of 1. That's why the coordinates of this point are x equal 1, y equals 0. Now, if I start at 1, 0, and I move t units along the circumference of the unit circle and end at any point whatsoever x, y, then here are the definitions for the trigonometric functions. The sine of t, that is the sine of this arc length here, t, is equal to y. So that y coordinate is the sine of this arc length t. The cosine of t is equal to x, and the tangent of t is y divided by x. So you can see tangent of t is still sine t over cosine t. Now, and the definitions for cosecant, secant, and cotangent are such that I can get these reciprocal identities out that I've had before. So cosecant is 1 over y, secant is 1 over x, cotangent is x over y. So these are new definitions for the trigonometric functions. It's our third definition, and it involves the unit circle. Now, t is not an angle here. It's real number measure. It's a length along the circumference of the unit circle starting at 1, 0 and ending at the point x, y. If I'm on the unit circle, then, the coordinates of any point on the unit circle are cosine t and sine t. Now, what I want to do is take a close-up shot of this and see if we can go back and draw in a diagram so we can get our original definition 1 for the 6 trigonometric functions back. So suppose I draw in this angle in standard position here, theta, angle theta. Now, theta in radians is going to be the arc length t divided by the radius of the circle, which is 1. So theta and t are exactly the same thing. That is, the radian measure for angle theta and this arc length here, t, are exactly the same. So you can even think of t as being angle measure. Now, let's go back to our original definition 1 for the trigonometric functions and find the sine of theta. Let's have a close-up here. So the sine of angle theta, well, theta is in standard position here. So all I need is a point on the terminal side. Well, x, y is on the terminal side. The sine of theta is the y coordinate divided by the radius, which is 1. That just comes out to be y. So you see that sine theta is equal to y, whether I use my definition 1 or this definition 3 that I just wrote. Now let me go back to this diagram and see if we can't draw something in and see what we can get for the sine of theta using definition 2. I'm going to draw in a vertical line right here so I get a little right triangle. So here's my right triangle. Here's angle theta. It's an acute angle in this right triangle. The length of this side is x, and the length of this side is y if this is the point x, y. Now I'll use definition 2 to find the sine of theta. The sine of theta, using definition number 2, will be the side opposite, which is y, divided by the hypotenuse, which is 1, so I end up again with y. So the sine of theta is equal to y no matter whether I use definition 1, definition 2, or this new third definition. So 3 different ways to define the trigonometric functions. All of them are consistent with each other. And one works well if we have the point on the terminal side of an angle in standard position. The second definition works well if we're working with right triangles. And this third definition works well if we're on the unit circle and gives us a way to have a real number measure for angles here. I can think of finding the sine, cosine, and tangent of an actual real number length right here. So as you'll see as we progress through the course, these 3 different definitions come into play in different situations. Let's go to the board now and look at our first problem. Let's use the unit circle to find all the trigonometric functions for 11 pi over 6. Now, what I've done is reproduce this little diagram out of your book of the unit circle that has all the angles, their corresponding radian measure, and then the ordered pairs where the terminal side of those angles intersect the unit circle. So here's a nice close-up of that. Now, here's 11 pi over 6 right here. Let me just draw a line in at the terminal side of that. It's right here, 330 degrees is 11 pi over 6, and I have the ordered pair square root 3 over 2 and negative 1/2. So let me write that right here. Square root 3 over 2 and negative 1/2 is the ordered pair at 11 pi over 6 units from the point 1, 0 along the unit circle. So that's the point, square root 3 over 2, negative 1/2. Those are the coordinates of the point where 330 degrees intersects the unit circle, or you can also look at it as the coordinates of the point that are 11 pi over 6 units along the circumference of the unit circle away from the point 1, 0. In any case, this is the cosine of 330 degrees, or 11 pi over 6, and this is the sine of that angle. So writing the 6 trigonometric functions is going to be very easy. The cosine of 11 pi over 6 is square root 3 over 2, which means that the secant of 11 pi over 6 is going to be its reciprocal, 2 over square root 3. Now let's see how much room I have, okay? The sine of 11 pi over 6 will be the x-coordinate, will be the y-coordinate, negative 1/2. So the cosecant of 11 pi over 6 will be the reciprocal of that, negative 2. Then the tangent of 11 pi over 6 will be the sine divided by the cosine, and the cotangent will be the reciprocal of that. So this diagram right here, as far as finding sine, cosine, and tangent of all these angles here, whether they're written in radians or degrees, turns out to be a very simple process. You just look at the coordinates of that ordered pair. The x-coordinate is the cosine of the angle. The y-coordinate is the sine of the angle. Let's look at another problem now. Problem number 2, let's find all theta for which cosine of theta is negative square root 3 over 2. So I'm just going to use the unit circle over here to find all the values of theta for which the cosine of theta is negative square root 3 over 2. So if I look on my unit circle, cosine of theta is the first coordinate of all these ordered pairs. So I simply want to look around for ordered pairs that have a x-coordinate of negative square root 3 over 2. Okay, here's square root 3 over 2. I keep going around. Here's negative square root 3 over 2. That's 150 degrees, or 5 pi over 6 radians. Keep going. Here's another negative square root 3 over 2 at 210 degrees, or 7 pi over 6. And that's all we should find, because x-coordinates are only going to be negative in quadrants 2 and quadrant 3. So by looking at the unit circle, I know that theta must be equal to, what was this, 5 pi over 6? Or this angle right here, which was 7 pi over 6. So a lot of these problems are just to get you familiar with using the unit circle to find cosine and sine of some of these special angles that are written in either degrees or radians. The next thing I want to do is talk about sine and cosine as being even and odd functions. Let's look at the next problem. But first, let's define what an even function is and an odd function. Remember from algebra, an even function is a function for which f of negative x is always equal to f of x. So you can replace x with negative x. It doesn't change the function values. If that's the case, you have what's called an even function. Now, cosine is an even function because the cosine of negative theta and the cosine of theta are exactly the same thing. Now, odd functions are such that f of negative x is negative f of x. So if I replace x with negative x in an odd function, my function values change signs too. So if f of negative x is negative f of x for all x for which the function is defined, then we have what's called an odd function. And now the sine function is an odd function because the sine of negative theta is always negative sine theta. For instance, the sine of negative 30 degrees is the opposite of the sine of 30 degrees. Sine of 30 degrees is 1/2. The sine of negative 30 degrees, that will be in quadrant 4, that's negative 1/2. So sine of negative 30 is negative sine 30, and that's why the sine function is an odd function. Now, next what I want to do is work a couple of problems that involve this definition, or I should say these functions. But anyways, let's try problem 3. Let's find the cosine of negative 5 pi over 6. Well, cosine of negative 5 pi over 6, because cosine is an even function, is the same as the cosine of 5 pi over 6. And now if I check on my unit circle, which I don't have right here, but if I just look on my unit circle, the cosine of 5 pi over 6 turns out to be negative square root 3 over 2. Negative square root 3 over 2. So here I use the fact that cosine is an even function to write cosine of negative 5 pi over 6 as just cosine 5 pi over 6. And I do that because cosine is an even function. Then I use the unit circle or whatever other means I have to find the cosine of 5 pi over 6. That turns out to be negative square root 3 over 6.